first thing is threading. Of course, I call it as threading in Go, even though we seldom talk about threads in Go, but ultimately uh, behind the scene threads are only the units that do the work, that, that does the heavy lifting of the work. But in Go, we call them as Go routines. Let's talk about concurrency versus parallelism. This is one of the uh, important concepts of Go. So here you could see that there are two images side by side. A kid is juggling with three balls, and then right side there is a kid who is juggling with two balls. So three balls means he has got two hands. That means two threads. So again, threads is very subjective. Usually, the number of threads a system can execute at any point of time is the number of cores of that particular hardware. If you are exactly speaking, precisely, it can execute only equivalent to number of cores of your hardware. That means your hardware has got 8 cores, then at a time it can run 8 threads. There is some virtualization came even on top of that. That is the reason in the latest processors you see 8 core processor and then 16 virtual processors. I don't think that is too much information about cores and hardware stuff, but what happens is the number of cores are actually run in parallel. Uh, Apart from that, anything else that run on top of those number of cores, those are all concurrency. So here, concurrency means a child is juggling three balls with two hands. That means three threads with the two cores. Here, the right side, a boy is juggling with the two balls with two hands. That means two balls are there in his two hands, and then he is juggling with two hands, and both the hands are trying to pick up, trying to hold the balls, trying to catch the balls. But in the left side, three balls are there. That means three threads that he is juggling at any point of time or any point in time. The boy can hold only two balls. That means one of the balls is in the air, which that is called the time that takes to juggle three balls is it's called time slicing actually, because at any point of time he can hold only two balls, but if you overall if you look at it, he is catching or juggling three balls. So the concurrency is ultimately doing multiple works, is what concurrency, doing multiple tasks or multiple executing multiple processes is what concurrency. Parallelism means doing multiple things or executing multiple processes at once is what parallelism. So concurrency and parallelism, many folks are too much confused about concurrency and parallelism, but both of them are different concepts. But uh, through concurrency, some kind of parallelism is can be achieved, that we will discuss later. So we know why concurrency is not parallelism, because concurrency means doing multiple tasks irrespective of whether there are 2 core processors or 3 core processors or octa-core processors. Parallelism is doing multiple tasks at once. At once is what I have to insist that at once is very important. So there is a wonderful talk by Rob Pike. Rob Pike is one of the inventors of Golang. Uh, you can see him because of his dressing style, and then of course his knowledge, and then his dressing style. He can stand out in the crowd very easily. There is a presentation about Rob Pike, a very old presentation. I think it is in 2014 or 15. YouTube is there loaded to YouTube. That presentation he explains very well about concurrency is not a parallelism. So he goes in depth into why concurrency is not parallelism, and then whatever I gave some information, he also talks about similar information. Of course, his knowledge levels are different, and he's the guy who has invented Go language. So Go routines, actually in Go language we don't call them as threads. So Go runtime is a really very genius runtime. Okay. The reason is usually what happened is, if you talk about generally concurrency or multi-threaded programming of any programming language. Let's talk about Java. When you are developing or you are writing multi-threaded application in Java, there are two kinds of threads. One is called green threads, other one is called system threads. So Java initially adopted system threads, and then in between, I think version 1.4 or 1.5, uh, they moved to green threads. Green threads means the threads are created by Java virtual machine. Green threads means threads are created by Java virtual machine. System threads, operating system threads means Java runtime. Every time a new thread is supposed to be created, Java runtime asks the operating system, it makes a call to the kernel, if it is a Linux system, if it is Windows system, Windows runtime, and asks, hey, I want a thread. Then your kernel processes and creates a thread and then gives back that particular thread handle to your Java virtual machine. That means anything that has to happen with respect to thread, maybe it is a creating a thread or joining a thread or destroying a thread or concurrently executing multiple threads, it has to, or a thread requires more memory, the memory that is given by our operating system per thread or per process is not sufficient, then every time it has to call operating system. Then the more frequently it calls the operating system, the more latency it takes to execute our application. Latency should be always, uh, you have to minimize the latency. That is how you can improve the performance of your application. So every time it has to call the operating system. Go again, Java came up with green threads so that it says that, no, I don't want every time when I have to create a thread, I don't want to ask the operating system. As a Java virtual machine, I would like to manage my threads that they started. But unfortunately, with the evolution of multi-core processors, that model did not work for Java because the green thread concept is around single-threaded applications, single-threaded environment that was not created. They could not scale up that. They could not scale that up to multi-threaded, multi-core processors. It could be one core, two core, or more than one core processors. Uh, that's what Java does. So they came back to creating operating system threads. But Go does a different technique here. First of all, we don't call them as threads in Go. It does not mean Go runtime creates threads. Go runtime creates threads. How many threads it creates? It creates the number of threads that are equal to your hardware. Let's say you have octa-core hardware, then the number of threads that Go runtime creates is 8. If there are 4-core processor, then the number of threads by default Go runtime creates are 4. Go runtime creates some threads. On top of those threads, thread is very expensive thing, as I said earlier. On top of those threads, what happened is Go runtime creates, whenever you want to create a Go routine, the Go runtime creates a Go routine. So what does it mean? Why? Because it doesn't need to ask operating system every time it has to create a Go routine. Because Go routine is not a thread. And then Go routines are managed and scheduled by a component inside your Go runtime. That component, we call it as Go scheduler. Go has got a scheduler. That scheduler is taking care of all the Go routines. So how the scheduler picks those Go routines are, uh, there are variety of implementations are there, but at some point of time they came to a conclusion. They came to a development stage where it has become very stable. There are some queues, actually internally it maintains some queues. For example, whenever you create a Go routine in your application, Go routine is nothing but a lightweight thread. The size of the Go routine is for about 2 KB, not more than 2 KB. If you are using more memory, then it exceeds 2 KB, but by default, or it takes 2 KB. Whenever you create a Go routine, a new proc or some method is called inside, and then a newly created Go routine is enqueued into a Go global run queue. there is something called global run queue. A newly created Go routine is enqueued to the global run queue. That means there is a queue. All Go routines are uh, standing in the queue, waiting in the queue, which is called global queue. Why it is called global is by default, Go runtime creates few number of threads. Those threads are equivalent to your operating system, your hardware. So these 4 or 5 threads, 4 threads or 8 threads that are created by Go runtime, those threads, the Go scheduler distributes these particular Go routines that are lying up in the global run queue to number of threads. That means it is called N is to M multiplexing. It is called multiplexing, N is to M multiplexing. That means one thread can run multiple Go routines. The exactly same way how your hardware thread can execute hundreds of your operating system threads. Similarly, Go scheduler and then Go runtime handles all these things. There is a global run queue and then there is a local run queue per thread. Uh, it handles global run through and then it handles global run queue and it also handles local run queue. Queue means, yeah, first in, first out. That means whichever the Go routine that is asked to create first, that would be executed or given to a thread at first. Right. So why Go routines are fast? They perform better than threads because scheduling is something that every time it doesn't need to ask the operating system to schedule. Number one, doesn't ask. They are very small in size. They are just 2 KB in size. And then they can grow or shrink in terms of memory based on demand. 2 KB, managing 2 KB is relatively easier than managing some MBs, right? Thread comes with some MBs, but Go routines are 2 KB and then they can grow or shrink based on the requirement. So Go run scheduler takes care of time slicing. Time slicing means there are 2 threads, but there are 200 Go routines. So what happened? There are 2 hands and then 3 balls with a guy who is juggling. Similarly, there are 2 threads. For instance, there are 200 Go routines. So how to run each and every Go routine is scheduled by Go scheduler, but not by your operating system scheduler. It is scheduled by Go scheduler. What is the purpose of that? If it is scheduled by Go scheduler, the purpose is very, very simple. If it is scheduled by Go scheduler, then it doesn't need to make calls to the operating system. The entire process of scheduling and managing Go routines are taken care by Go runtime. Doesn't it need to, Go runtime need to communicate to the operating system? Yes, it does. It has to, because ultimately those are threats, but it doesn't need to communicate so frequently that any other multi-threaded programming application has to. That is one of the best thing about Go routines. So Go routines are, so coming to parallelism, we are talking. So do Go routines run in parallel? Do Go routines run in parallel or concurrently? We cannot say basically. It is the decision that is taken by the Go runtime. You cannot ask any Go routine to run in parallel. You cannot. There is absolutely no way. But the runtime is optimized in such a way that as and when possible, it tries to execute Go routines in parallel. That means it tries to place multiple Go routines on multiple threads. So there are few Go routines. They may run on in parallel, but ultimately we cannot know whether they are running in parallel. We can go and check sometimes, but we cannot know. We cannot decide. Basically, we cannot decide that, okay, hey, Go routine 1, please go run in a parallel on a separate processor. Hey, Go routine 2, please run on a separate processor or separate thread. We cannot do that. That particular decision is taken care by your Go runtime. So generally, the concept is like I develop one example, I give some theory, I develop some example, and then I show how it works. What is Go routine? How to create the Go routine? What are the rules that you have to follow in order to create Go routines? All these things generally uh, in sessions. That is how it goes. But this particular presentation is the solo purpose of this presentation is just to give just a glimpse of what is concurrency, what is the difference between concurrency and parallelism, and also to say that concurrency is not a parallelism. Yeah. Thank you very much.
Thank you so much, Jitin.
Yeah.
Yes, so you can leave.
Hey, can you send me that presentation to me as well?
Sure, sure, sure. Let the processing is done. I'll check.
Yeah. Thanks, man. Bye.
Thank you. Bye.